Like, because it thinks it's the in.
Are you using multiple, are you using white space in the name of your variable? Like a space?
Between the n and the equal signs.
So the only thing to keep in mind is that variables have to be one continuous object. So for example, if this is, if the variable name is when in Rome, it has to be when underscore in underscore Rome. Otherwise, it'll think that it's three different things because white space indicates the end of whatever object you're looking at. Whoops. Should probably not be projecting this.
I sent you, you said just send it to you on Slack, right?
Yeah. Okay. Does that help or no?
I still get invalid input.
Okay. We'll do that in 30 minutes. Does that sound good? So today, Trinity is going to tell us about 2.4 lists and arrays. And then what we'll do after a great presentation is we'll break up into the same groups that we had on Monday. And I think everyone was stuck on Catalan numbers. So what we'll do is we'll sort of workshop how we break down and attack problems before we start writing code. We'll fix that one, and then we'll do the two practice problems of today. Now you have a homework due. That'll be due this Friday. So if this is brand news to you, sorry, it shouldn't be news to you. Okay. Right. You'll figure that out. That doesn't count. And then you'll do an introduce yourself. We did introductions last Wednesday. Major, preferred name, pronouns, when you're graduating. What do you want to get out of the class?
And your major.
Hi guys, my major's physics. Senior, right? Pronouns he, him. Fall 2025 and graduation.
And what do you want to get out of this class?
How to analyze data and plot correct.
Cool. Love it. All right.
Oh, I don't get an introduction?
You
kind of just I'm kidding, I'm kidding.
I didn't give Elliot an introduction.
Oh. Okay,
So would you prefer
where's
to have this up right now, or do you want to have the PDF up?
PDF. How come that doesn't look like that? You don't have it mirrored?
No.
That's crazy.
I know, right?
Because I couldn't do that.
Professional like that. All right. This one?
No, page 46. Oh, I guess yeah, just enter that.
Do you want one page or two?
You just leave 2 for right now.
Okay.
Okay, so 2.4 is about lists and arrays. And in the textbook, it talks about in Python, there's a feature that is used to store collections of numbers, and those are called containers. And so these containers, there's many different types, and 2 types of those are the lists and arrays. We'll go over their differences later, but the first one is lists. On the right-hand side, you'll see that it says it is the most basic type of container in Python, where it basically just, it uses this definition, but it's a list of quantities where each quantity is an element within that list. Some of the an important thing to highlight for list, that first sentence in the second paragraph is that they don't have to be all the same type. So like integers or float, that's they don't have to be the same. So that's a good thing. Can you go to the next page?
Yeah.
I'm sorry, I would do it, but I can't.
If you look to the left and you just do this.
Oh, thanks. Okay, so then on the left here, it has like an example of how you can set a variable equal to a list, and that's right here. So they just made a random list and set it equal to R, variable R. Once you do that, you can just print it. These are just examples, very elementary of how to make a list in Python. Over here though, what it talks about when you set a list equal to a variable, one thing that you have to remember is that Python, when you set this type of thing right here, like R equals XYZ, it reads from right to left. So it defines XYZ first to be equal to R. So if you want to change an argument, an example I have, how do you?
You got it.
No, I'm trying to go to the code calc now.
Yeah. Your clicker was on it.
Is this it?
Yep.
Okay, so for an example, I made one like here. So for a list right here, I import math, okay, X, Y, Z, I set it equal to 1, 2, 3, and then here's a list right here, variable I set it to is X, Y, Z. If I print this variable, it's gonna pop out 1, 2, 3. But if I want to change the first one to 5, if you see right here, I put X equals 5 and I click print R again, it didn't change X, and that's because you have to define the variable again. So an example of that is right here. If you re-add the variable R, then because it's reading from the right, this is equal to this, it goes back and it reads that, oh, X is now 5. That
Does
makes
that make
sense.
sense? Any questions about this? So notice one thing that Trinity has done here is, she's created this list, and this is very similar to your arrays, right? So your vectors that you find in physics. So a lot of the same things that we think about, whether they're vectors, matrices, it's duplicated here in Python. And the only difference is, as we get into talking about the difference between lists and arrays, it's the types of stuff we can put into them, right? So right now, this reads exactly how you think it would read. Item, item, item. It just happened to be integers. But the list doesn't know, right, for example, that they're going to be integers when you write R with that bracket.
Okay. And then how do I go back to the textbook? I'm sorry, I always feel like an elderly with like the
That's all right.
technology. Oh, thank you.
Yeah.
Okay, and then so moving from there, what else do they have? What did I want to highlight over here? I think there's just another example of some arithmetic you can do within lists. And that's the example right here. It's pretty straightforward. You have this variable set equal to these floating numbers right here. And then you can use this thing called length, and then it uses this function across every single one of those elements. And then because you set this equal to its own, I want to say its own formula. I don't know how I want to word that, but it prints out this right here. So this is actually a function acting on the whole list and only having one output, not printing out the variable again.
Do folks recognize what that is? Little section, what would we call that in mathematics?
Yeah. No.
Can you see that? So this is the length vector, x, y, z. X squared plus y squared plus z squared, all square root.
Finding the magnitude?
Almost another way for saying that in physics.
That's like what you do.
Almost there. What? It's right here, y'all. The length. You go x, y, z vector. You're getting the magnitude of the vector. That's correct. We call that in physical things, we call that length. Right? This is also sometimes called the distance equation. And this format of having 3 values, you're going to use a lot because we're going to do physics, right? So if we want to simulate a ball, we want to simulate the x, y, and z coordinate. We're going to use R, but we're not going to be in spherical coordinates. That's just another length, right? If you want to use a better letter for that, I would strongly recommend it.
Okay. So the next thing that it talks about is that we could change the values of individual elements in the list. So instead of doing what I did earlier, which is resetting x equal to a new value, what you can do is you can call the element by did I go to the next page? What did I just do?
Yeah, just scroll up a little bit.
I can't. Anyways. How do you? There you go. All the way to the top. So right here, you have to remember that when you have elements within a list, the first one is always like the zeroth place. And then it goes from 0, 1, 2, 3, 4, 5, however big your list is. So if I want to change the value right here of this 1.5 to 3.5, I can call that the first place of the variable R. Then now when you print it, now it prints this right here. So you can change it that way too. Those are just two different ways. The next thing that it talks about is that Python also has the ability to perform an operation on an entire list, which is this right here. Some of these things, these are just functions that are built into Python. There's a list, there's a website at the end too, where it shows you what you can use. This is an example of using the sum. So all this is going to do on this list is add those all up and then you get this. This one right here is an example of,
Oh, wait.
no, go ahead.
I just don't know. I don't understand why in the top, the very top one,
Uh-huh.
why if you plug in R1, you get just a 3.5. Like I'm not understanding.
Oh, that you're making that change. So like over here on this one, when I just wanted X to be 5 instead of 1, they're just saying R, I want to change R now in the first place, the first position in this list to 3.5. It didn't just pop up.
You see how the 1.0 didn't change to 3.5?
I see.
Only the middle one changed. So like,
Because
are you able to?
Yeah, so we should be a little clear on the word here. You're saying the first position, which is correct because number 1 represents the
Yes.
first, but we count from 0. So usually we say the 0 position or the 1 position, as opposed to the first, which sometimes means all the way to the
Okay.
left.
yeah, it goes from 0 to 1. Like this, it starts from 0.
Okay.
Yeah.
Thank you.
It's okay. I had to do I when I was doing this example, I said, why didn't it change the first one? So yeah. So then this is just an example of it using sum, the sum function. And then this one right here is it using max and min, which gives you the largest and smallest value within a list. And then what do we use that for? Or we also have len, which calculates the number of elements in the list. So that right there, what is that? Well, we know in math, that's an average, or we can set that equal to mean. And that's what they do right here. The next thing we have is that there's a special thing within a function in list called map. But what a map does is it can take a math function and apply it to all the elements within that list. And this one's kind of interesting because even though you use this mapping function, it doesn't automatically print out that list for you. You have to recall it a list. What it does is it says it in here, it saves into the computer memories into something called an iterator. So it saves that information, but until you call it back as a list, it's not going to show you it as a list again. So I made an example of that so you can see what I mean. So right here, for example, I have XYZ, and this time I just set them equal to 2, 3, 4. And then I have my list set equal to this variable, so R is XYZ. And I want to take the natural log of this whole list. So what this is doing right here, I'm just using log from the imported math package. And what it's going to do is it's going to work on every element in R using the map. But when I do print log R, print this variable, you see right here, it didn't work. It says map object at, and this whatever. Maybe that's a space in the computer. I don't know. I'm not that smart. But so if you compare this code, to this one I redid it on here, you see how I add the list now? When you add the list function on top of the map, then when you print this variable, it'll show you all what it did, the math it did to all the elements in R. Does anyone have questions about that? I just thought, yeah.
So what's the big difference if you remove and just try and do the math log R to the whole list?
I don't know. I don't think I'm assuming that it wouldn't work on the whole thing. I don't know. That's a good question. I don't know.
It's a very good question.
I'm gonna copy and paste it and do it. Let me see.
Yeah, so we could test it, but let's also remember that we're talking here about lists. Was there any specification that lists have to be all numbers?
No.
No. So you could do what you're saying, but we will do that to things called arrays. that we are going to designate as being specific types of numbers, either floats or integers or complex numbers. And then you can perform mathematical operations on them because the computer's not worried, right?
Mhm.
If you try to do that right now, and let's say you do, you do log of the entire R, but you put in Y, you put like the word banana, right? It will operate on everything else, but the one in the middle will have a hard time, right? Because it doesn't know how what log banana is.
Could you also use a for loop to take the index, do some operation, and then append it to a new list?
Yes, absolutely. And we will use that in particular in this class.
So going back, the next thing it does talk about is the append function, which right here is what it does is it takes out an element within your list and
Takes out or
no, hold on, I think I said that wrong. No, it adds an element to your list. Okay. And so if you want to add an element at your for your list, you just put append and then whatever the actual element you want to show up in the parentheses, and I'll add that to the end of your list. And there's an example of that on the next page, which you'll see here. So this one right here has a variable set to these numbers right here. And you want to append 2 times x plus 1, and you already define what x is. It'll do the math right here, 2 times x plus 1, and then that whatever that value is, which is 2.6, it'll add it to the end of your list, and then you get a new list when you print R.
can I just pause for a second?
Mhm.
So one thing I want people to start noticing here is it's R dot append, right? So we saw this before, math dot log or math dot pi. What is that saying? That's saying that this function exists within the framework that's being called here, R. But you're thinking to yourself, wait, isn't R just a variable? Right? No, R is a list. So until you tell it that it's an array, right? Because arrays don't have functions that are special to them. They act much more like X or Y or Z or something normal. But R's are very special. Lists are very special, right? So they have a whole family of things that they can do just on their own. Does that make sense?
Are arrays and vectors considered different? Like it's different kind of property?
There are no vectors in this world. There's only lists and arrays. And the vector, really in math, doesn't exist either. It's just a multi-dimensional array, right? A vector is a special case of a 2D array. And similarly, we'll start getting into more than 3D arrays or tensors, right? But we'll still only call them arrays. And that's just really just to simplify the language. So you either have scalars, like a single number, you have lists, which can be anything like that, or you have arrays with our numbers.
Okay. One thing it mentions in this section too is what the empty list is, or the empty set. And so right here, you can set a variable equal to an empty set or empty list. And then if you want to add elements to that, you could just keep appending to, like what Dr. Kazmani said, that list that we called R. And so that's what this person does right here. They have an empty set. They append these 3 numbers, and they're just going to go in order from the code, and then it's going to shoot that out as your new list. And then the opposite of this, which is actually taking away something or removing a value from a list, is this one right here, r.pop. So it's just the opposite of the append, and then here's an example of that right here. So the array or the list first had 4 elements, and the last one was 2.6. When you use this function here, you take away that last element in the list, and this is what you get instead. And I'm pretty sure they're defined to always be the last element.
Yeah, unless you want to be specific. You can identify which one you want to pop by putting something in the empty parentheses.
Mm-hmm.
So at the very bottom, it's the R pop 0 gets rid of the first element. And you'd be surprised how important it is to sometimes pop that first element. Let's say you initialize something with some random number, and then you want the simulation to run. But you want it to throw away the very first time that you did it, because that's based on garbage. You just pop the first element of the array.
Where you put 0.
Yeah, it's pop 0. See down there, it's pop nothing.
And then there's one right here.
So then it would pop the last one.
So it's by default, it pops the last one, but you can pop in any direction. So if you have a 10 element list and you want to pop the 9th element, you do pop 8. Right?
If it's too big for the dimensional list, will it just take away the whole?
We'll get,
You're gonna see that in a few seconds.
you'll see that. Any other questions? You have one?
Oh, I was gonna say, can we go the other direction where if you want to get like second to last and say that there's like 100 of them, you can do -2 and go the other way?
Yeah, counting backwards.
Alrighty, so then the next thing is arrays. Right here, it kind of it labels the two very distinct differences between lists and arrays. Again, they're both containers within Python. One of the things on here that it says, the first thing is that the number of elements in an array is fixed. So you can't add elements. So those functions that we just talked about, the append and the pop, you can't do that with an array. The second thing is that the elements of an array must be all the same type. So that's floats or integers. They would have to be all the same within that array. And you also can't mix different, that's the same thing. You just can't mix them. You can't have different types in there or else it won't work. One thing I put here, if you're like me and you have to think about this more of like how are you going to remember this? I wrote that lists are like Silvertooth kids. You guys know I love that joke. Silvertooth kids. They're free range. You do whatever they want. They have less boundaries. And then arrays are the ones that have like straight A's or the clean cut student. That's what I wrote. So that's what's going to help me remember. The next thing, you never heard of a Silvertooth kid?
No.
They're bad kids. They don't listen.
It's good thing I don't have any, right?
Not yet. And then the next thing over here is that, okay, if knowing that these two things, if there's more restrictions on arrays, why would you use them? So right here, it has 2 good points as to like advantages as to why you would use an array. The first one is that arrays can be 2-dimensional, like matrices in algebra. And then, which it can have any number of dimensions. And then over here, arrays behave like vectors or matrices. So you can do arithmetic with them, which we'll see on the next page. Oops, did I just skip 2?
And I'll just clarify one thing here. Will, right? To your point, lists don't know what's in them, what their type is. So you can get around this by making a list of lists.
Is that, so they can't be 2-dimensional, but they can do that, right?
Yeah, and it's gross. It looks nasty, but it's really helpful sometimes. So for example, if you want a 2D array, right, it has to be square, or you have to, or rectangular. It has to be all the same. But what you could do is you could make a list like that, and then some of them are short lists, and some of them are long and short and long and short. It's not illegal. You can trick the computer into doing it.
And then the last thing it talks about as an advantage is that arrays are they just work faster than lists. So that's another advantage there. The next thing it talks about is using packages within arrays. So an example, one of the packages that it likes to use is zeros. This is explaining what zeros are. It's just the pack, like all your elements are going to be zeros, which is shown here. And the difference, how you can see if it's an array or a list, is that right here, there's no commas. It just has the elements and then shown with spacing in between them. So you can see what's in the array. I want to show. I think I have something in my code over here that I want to show. Let's find out. Okay, so right here, I just was messing around with like the zeros function, I guess, within the NumPy package. And so right here, what you can do with an array is that you can put how many elements you want and what type of numbers those are, the type, okay? So right here, I have I want the zeros function to be put in all my elements. How many elements do I want? 4, and then I want them all to be integers. That prints out this first thing here. The second thing you see is that I want this now to be like, well, what you mentioned, this is 3 by 3 now. This is a matrix, but I want them all to be floats. So I do the same thing with zeros. Now you see I have a 3 by 3 matrix, and now they say 0 point. And so it changes the type of zeros you're using. After that, it mentions that there's a thing called ones. It does the same thing as zeros. So it has an example of what ones can do. Is this the right page I'm looking at? Yes. And then at the very end right here. How does it different? Oh, it doesn't. And then one last thing it mentions right here, in this last paragraph is converting a list into an array. Which you can do, it has the function array exists in the NumPy package. So right here, there's a list that's 1.5 and negative 2.2. And then you could change that to an array of this variable, this list here. And then like Dr. Krismani said, it also talks about lists, like 2D arrays, which is an example here. To be honest, when it was talking about this, it says I kind of didn't do an example of this one right away. So this is showing you how you can take an array and create a list. So what you see is two variables here. Well, they're lists, right? You notice how they're lists, they have the brackets, they have commas. And so what I'm going to do is that would be my first element or my first row within the array. You see how that comes down here? Same thing for this one. Here's my second one in these brackets, and then it becomes the second row for my array. And then keeping them all integers. Does anyone have questions about that part? And then, like Dr. Kusumani said, because they're matrices, if you don't have the same number of elements for each of the rows, it's not going to work. The computer doesn't like that. So you have to make sure the elements are the same. And then the next thing we have, again, if you wanted just to change a certain element within your array, you can just call it by its placement. I think... yes, it still starts at 0. So that thing we talked about earlier with Kevin, the placement still starts at 0. So that stays the same for arrays. What's this example over here? And then the last thing that we have for this section is that, I mean, I'm pretty sure you guys noticed from over here that the first integer, when you use this type of formatting with the brackets, it tells you how many rows and then how many columns. Kind of like when you just do matrix multiplication, you got to remember the rows and the columns. That's how they're labeled, kind of like X and Y. It's always in that order. And so right here, if I want something 2 by 2 matrix, that's what this is saying, but I want the placement in the 0, 1 position to be 1, it pops out a 1 right there. And then in the position of 1, 0, so my row and column is -1. Actually, that's not correct. Yes, it is correct because it starts from 0. Yes.
If we, writing the code A equals array, then the list 1, 2, 3, 4, 5, 6, print A, and then we do A index 2 equals 4, what happens?
I think you would have to recall that A equals the array again, and then click print, and then it'll print it with the update.
What would happen with which element would get first?
Oh, which element?
Would be,
So if you call, so you're asking for this one here, right?
yeah,
Because this is inside of this.
Yeah.
Right? And before we do this or after?
after that, when if we.
After you make the array?
Yeah, if you put in that code and run it after you make the array.
Yeah, so this one here is gonna be, it's gonna change the entire thing,
Oh.
right? Because you need to give it a 2 location in order to specify a single element. Otherwise, it's saying the whole row or the whole column. But if you did this, if this was your list, right? And you said, I want to change the first element to 4, it would get rid of the whole list and change just this element into the number 4. Does that make sense?
Would you get an error since there's no third, element?
Oh, yeah, I mean, I don't know. It depends on which of the numbers, yeah.
Okay.
Right. Well, it does have a third element. This one here. Talking about that one. A2. Oh, no, this one and this one, yeah, there's 2 elements, it's 0 and 1. But we can try it. You know, Most fun you have is when you play with the game.
Mhm. Okay, and then the next section talks about reading an array from a file.
I don't know if we'll get that far today,
Okay.
so we might pick this up after you've done a really good job. I want to make
Oh, no, you're
you're
good.
not up here the whole time. So any questions for Trinity?
No, they don't.
Okay, no, they don't. All right. So also I'd like to introduce Sarah. Sarah's gonna be our LA this semester. So if you have questions and you're like, oh, I don't want to look stupid, you can ask her. She's very approachable, she's very smart, and she's gonna help you with everything this semester. I have office hours, but I would also like you to consider going to her office hours if she sets them up and they work for you. If you want to work on homework, if you want to work on pair programming, we're both going to be in here kind of running around. And if there's anything that she can't answer, I can obviously help as well. Do you want to introduce yourself? Do you know everyone? Does everyone know Sarah? Wow, except for me. Okay, cool. Thanks, guys. So let's do.
You're good, you're good.
Where is the homework? Right here. It's a little far behind. Yeah, I'm working on it. I'm working on it. But these will be the problem. We'll do 2.4, 2.5, and 2.9. Notice that the first homework is homework 0. That's what I'm trying to do there. It's just in the wrong location. It's supposed to be here. And it's supposed to be the 30th? No, the first? When is the first? Okay, 31st. I'll fix it. Don't worry about it. Yeah. You don't submit anything. So the cool thing is that you just work in your folder. You create the homework and then I just collect it. And you won't notice that it's happened, but I will see the current state of your homework. Yeah. If you want, at that point, I can like write comments. I can't write comments in your code. You won't see those, but I can write there's a little text box. It's a really small text box. So typically that's a shitty way to give comments on a very complex code. So if you're having trouble with something, I almost always recommend communicating. Because unlike, just getting a number being like, oh, number 4 is right, good. You most likely will be like, wait, is this code written well? And I look through it and I go, no, let's try this, this, and this, and you're going to be writing much better code, right? Yeah.
Two things. One, what can we name the Jupyter notebook?
You will have a folder assigned to you. It'll be called homework 1, and then you'll just call it whatever you want.
Let me in the project that you made.
Yeah, everything has to be in the project that I made because otherwise I can't collect it from you. You can, and we'll talk about this later. Let's say you're working on your own or you're working in a different project. You can upload files into your project. So if you're working in your own personal project and you want that to show up in the one that I created, that's perfectly okay. You just download them as IPYNB files, then you upload them. Right? Yeah.
So for clarification, the homework is due this week and not next week.
All right, fine, next weekend. Next Friday. But that means you got to do a lot of pair programming. Okay? We're going to finish all the problems today? Maybe not. We'll see. Okay. Yeah, and I always like to build in Slack. I mean, you're learning a bunch of new things all at once, right? So it's going to feel really daunting and it's going to feel really horrible. But once you start getting the hang of it, you're like, oh, okay. It's a steep learning curve, right? So for today, I would love to finish up pair exercise 2.7. I think there were some people who weren't here. So Emmanuel wasn't here on Monday. And Metzley, you also? Do you guys want to pair up with Trinity? 1, 2, 3. Wait, hold on. Let me count again. 1, 2, 3, 6, 7, 8. Damn it, that's an even number. Who are you working with? So now, are we missing someone? Lucia. Okay. All right. Classic. Someone's always, like there's always someone you have to juggle and move them around. Okay, so we'll reorganize everyone in a few seconds. Let's try and finish 2.7 and then we'll jump into 2.8 and 2.10, which are going to use those lists and arrays. And if we get far enough that we need to download data to look at the sunspots, I'll kind of do a presentation on that to make sure that we're all on the same page. Does that sound good? Okay, so if you had a partner on Monday, find that partner. If you don't have a partner, work with someone new that I just talked about. And if you're alone, because Lucia left, let me know. You're alone because Lucia left? Okay, who do you want to work? Remember that you only get to work with one person 1 week, right? So like you'll make one pair and then you'll never get that pair again. So it depends on when you want to use your friend.
I'm sorry, how are you going? So that we can finish up 2.7 today?
Yeah, same pair. So you get one pair for the whole week. And then you get a new pairing the next week. Yeah. Yep.
We'll need to partner. Gotcha. Alright, you wanna be up here then? If not, I think-
I don't see the projects or the cookout. I'm not sure like where, I mean, it's not here, but
Okay, so you just started it, right? Did you send me this email?
I sent you a message. Right here.
It's because it's just gonna be for today, that's all. And then it will switch up and I don't know, that's all.
For everything else done?
Just for this week.
Let's do it, yeah. Give me a second and I'll be right there.
Yeah, it's in the syllabus and there's a website. for that. At least for this week. Then you also do,
Log into yours because I'm still on 9 o'clock.
I can't seem to find the PDF. It's been filed. I'm not sure.
Emmanuel, you just sent me your email for Coco? Yeah. Okay, I'll add you too.
Um,
What's your email address?
007-616-746 at coyote.csusb.edu.
Cool, gotcha. Okay, let me see. Oh, is that right? Yeah. On Zoom? Yeah.
Cause I just like, it's great to me.
Okay. Yeah. I mean, we have time, so take as long as you need. If you want to go home, if you're not feeling well, it's better for be healthy than to. Okay. For this or first thing? Yeah, of course.
And then.
Oh, right. Did you send me an email about that? Okay, so send me an email with that and then we'll talk to no, it's okay. CC me and Maureen. Okay. Is this the correct email?
Where is it at
Here.
again? Oh, 007-616-616. Yeah, it looks good to me.
Wait, so Trinity's alone now? Is that okay? Yeah. It says you're already added, maybe?
Huh. I guess I'm not sure where I'm supposed to click on here to.
Hold on, let's double check. Brandon, right? I don't
Yeah.
see you.
Huh. That's
I just posted this.
there's a glitch. The matrix.
Is that right?
There is no spoon.
Brandon, what's your last name?
Jimenez with a J.
Let me clear my schedule really quick. I just want to.
Are you sure you signed up under that? Can I see your CoCalc?
Yeah, my account.
Yeah.
So email address, it's right there. Yeah, that's weird.
Okay, hold on. Search by Jimenez. Maybe the search is not exhausted. Do you have a question, Will? Yeah.
So Emmanuel is in the class and hasn't done 2.1 or 2.2 exercise. Do
Mhm.
we do that now or do we just do 3.3?
So Emmanuel has done this class before, so he should be fine not doing 2.2 and 2.3 if he doesn't want to. Emmanuel, do you really want to do 2.2, 2.3? Okay, then just jump into 2.7.
Oh,
Okay.
yeah,
I still have-
better.
No,
I still
not that far.
2.3
Oh yeah, do 2.3 with him. Yeah,
Okay.
yeah.
and then
But don't let him just barrel you over because he's done it before.
thank you.
Is this you?
In a minute, 000. Yeah, that's me.
No email associated for some reason.
That's weird.
Let's try the email again. 00.
7616-746. Yeah.
Doesn't matter though. That's fine. Oh, yeah. Yeah.
Yeah.
Already added or deleted.
So I remember.
Oh, yeah.
We were.
Yeah, it looks like.
I guess I'll. Oh wait, I think I see it.
There you go.
There it is. Good to go.
Okay,
All
awesome.
right.
Let me
So
add Soto as well.
is this where we do our
Get to start the project.
oh
Anyways.
where do we find the homework? Is that on CoCalc or is that in the textbook?
It's in here.
Yeah.
Like these problems.
Like the
The assignment is here.
right, yeah.
These
so
problems.
2.4, 2.5, that's from the
The textbook.
Okay,
Yeah.
okay, got it. Sweet. Thanks a lot.
Yeah, no worries. Emmanuel, I don't have a Slack message from you. Oh, that's weird. Here, do you want to just add your email here? 0699
006.
00699
26.
2629 at Coyote.
Yeah.
Perfect. Gotcha. Okay, so now that everyone's in pairs, let's talk about how we're going to attack 2.7. Because I think folks are stuck. Is anyone stuck on 2.7? Everyone. So let's think about how we break this type of a problem down. Where is it? Also, I don't want my face in my face. Okay. All right. So these are the Catalan numbers, a sequence of integers that are important for a number of reasons. That doesn't matter. You've been tasked with creating them. Okay? So you don't care about the physics at all. You're just here to make numbers today. So you see two equations. You see one that doesn't depend on n and one that does. So you're thinking to yourself, okay, how do I go about creating all of the Catalan numbers? Well, I'm doing some form of a loop, like a while. So let's just check all of these numbers below 1 billion. So while the second number, Cn+1, is less than 1 billion. That'd be my while statement, right? So if I'm thinking about this, I'm going to write it out ahead of time. I'm going to have something like a while Cn less than 10 to the 9. And I'm writing this for me, So I'm not gonna write it in code. Okay, then I'm gonna have some loop. Stuff has to go in there. I have to know that I'm getting it right. So I know I need a print statement, right? So I'm gonna put that at the end. And I know I need these two numbers and they depend on each other. So, what do I do here? I know I need these two numbers. I know they depend on n. Okay, so maybe I got a little eager. Let's start by defining these numbers. So maybe I'll start with C0 and Cn, right? And I'll write that they're both equal to 1. And I probably need to define what n is. So let's write n equals what? Well, not yet. Look at it here. So C0 is 1, Cn is 1, so n must be 0 or 1. Either one's fine, right? You can start at 1, you can start at 0. It'll have the same effect. And you can prove that in 2 seconds, right? So let's start with 1. And now I have a while loop. And this while loop will actually run because Cn will be defined, right? Before, it'll just complain because Cn wasn't even told. Yeah.
Is the CN initializing C0 and CN before the while loop?
Yeah, this is out ahead of the while loop. Yeah, so this stage would be called, as Will just said, initializing variables. You need to define what the variables are, what type they are, and what they're made of, right? So this is the names of them. They are no, they're not flipped.
Real quick, how do you put subscripts?
Just destroyed the chalk. I would recommend it. Don't make your code look good. Okay. Don't add Greek characters. Don't add subscripts to your variable names. Be descriptive, not fancy looking. You want to avoid every math instinct you've ever been taught, right? This is not like a Greek class. This is talking to each other class. So in fact, Cn, kind of a shitty variable name. You could just as easily say and that would be a lot more helpful, right? And then you could do something like, instead of saying Cn, you could say right? And wouldn't that make sense intuitively? And then when you write it out, you can just copy paste that. So you don't have to physically write it out. Okay, so then when we think about this bottom one here, we say Cn plus 1 is what? What would that be? How would I write that? Next, well, we're close. Hold on. So the n is being plus 1, right? But what is Cn plus 1? It's this stuff, guys. Here's all that. Right? It's whatever the last Catalan number was, plus whatever this garbage is. Right? Okay. So the next one depends on the starting one. So I can write that. So I can write next, and I'm not going to write the whole thing out because I'm not copying and pasting, is equal to 4n plus 2 over n plus 2 of starting. Right? Am I done? No, what else do I have to do?
Print.
Good, I need a print. I'm gonna print next and assume that says next. Is that it? Well, we don't know what range is yet, right? 'Cause we're still in, we haven't even learned about lists or anything.
Need to make it so that CN changes.
Well, CN is gonna change, right? Isn't next gonna change? What's not changing?
See,
What?
starting.
Oh, and he's equal to one.
N is equal to 1 is not changing, good. Starting is not changing, good. Okay. So first, let's address the first problem. How do we get N to change? Okay, so now I can go in here, I can say N plus equals 1. And then? Isn't N plus 1 equal to next already? Should I go back to Cn, C0? Okay, this one here, just think the word next. This one here, think the word starting. Okay? So you've updated next, and now what do? You print it, and then update the start to be
The previous next.
the next that you just calculated, right? So what's that? What happens after you print next?
It'll start. Yeah.
Yeah, but you want to do something after you print next.
Continue.
You just said it. I'll just said it right here.
That the starting is that next,
Good. So say that again. And
but that the starting is now that next.
and is the word equals. Thank you. So start equals next. And then it'll loop. You see? Do you see how this process works? We have two bins. Okay? One bin is 1, one bin is 1. This is my next bin, this is my starting bin. The first thing I do is I update this bin based on the contents of this one. And now this is a new number, let's say 2. Then I swap them so that I don't have to hold hundreds of pieces of information, and I update this one. And then I swap them and I update this one. So I'm always updating only on my right side, your left side, but I'm swapping where the information is throughout the course of the algorithm, right? Does this process make sense? Does the way that I wrote this out on paper make sense? Because you should be doing this. You should draw out how they're physically going to interact, because by the time that you're doing these long, complex pieces of code, you'll have modules and you're like, what the hell does this even do, right? So you kind of want to think ahead of time, ahead of all the things that are going to change and how they're going to change by writing it out, right? And then you've done half the code.